Quadratic formula is another way to solve quadratic equations. Let's see if I can fix this here. No, I guess it's fine. And discriminant is a new vocabulary word that we'll talk about that will give you information about what to expect with your solutions. I do have a handout for this in class. Okay. If you look in your notes, it says understanding the discriminant, and there's discriminant. This is part of the quadratic formula, b squared minus 4 times a times c. And the number of real roots, sorry. Roots are a new vocabulary word as well, and that means solutions. So we'll solve for x just like we did when we were factoring. If the discriminant is greater than 0, so this is a positive number, then you'll have 2 real number solutions. If b squared minus 4ac is equal to 0, you'll have 1 real number solution. And if b squared minus 4ac is less than 0, then you won't have any real solutions because your solution is not a real number. As you found when we're reducing radicals, sometimes you have an imaginary solution. And that is when just the part that you're taking the square root of is negative. We will use quadratic formula when factoring is too difficult. And that happens sometimes. Sometimes you get wonky numbers and factoring is not reasonable. There we go. To use quadratic formula, you will need to have a standard form equation. Ax squared plus bx plus c equals 0. And the first step in solving will be to find the discriminant. That's this part that's under the radical. So this is what we're going to do first. Okay, here we go. To find the discriminant, the instructions are give the number of solutions and do not solve for x. So what we need to do is identify a, b, and c. We need an equation that's in standard form, n equal to 0. We need to identify a, b, and c, and then we'll substitute into just the b squared minus 4ac part of the quadratic formula. For this equation, it's already in standard form. It's equal to 0. A is 1, b is negative 10, c is negative 11. So I can substitute into this discriminant formula, and I'll write, always use parentheses when you substitute. Let me just set this up to substitute here. I'll write b and a and c into these spaces. B is negative 10, a is 1, c is negative 11. Negative 10 times negative 10 is 100. And then negative 4 times 1, that doesn't change anything, But -4 times -11 will be positive 44. So my discriminant is equal to 144. Since I got a positive number, I can say that there's two real roots. The next problem right under here is not in standard form. So I need to move this 10 so I can set my equation equal to 0. I have now x squared minus 6x plus 10 equals 0. So A is 1, B is -6, and C is 10. We're finding B squared minus 4AC So, all right, -6 squared minus 4 times 1 times 10. And -6 times -6 is 36. Minus 4 times 10 is minus 40. I get -4. So here's my, got a negative number. That'll be less than 0. So I won't have real number solutions. I'll have imaginary solutions. I'll have 2 imaginary solutions. I have 2 more here. Let's go around in a little circle. 3x squared plus 5x plus 4 equals 0. So A is 3 now. B is 5. C is 4. B squared minus 4AC is 5 squared minus 4 times 3 times 4. 25 minus 12 times 4, 48. That'll be negative. So again, I have 2 imaginary roots. Because this will be under the radical, and I'll have to do square root of -23. That's imaginary. Okay, one last one. Not in standard form. Move the 7. New equation is 2x squared plus 6x minus 7 equals 0. A is 2. B is 6. C is -7. So I'll have B squared minus 4AC 6 squared minus 4 times 2 times -7. If you see, if one of the numbers over here is negative, then that will negate this and you'll have a positive answer. 36. Negative times negative is positive. 4 times 2 is 8, times 7 is 56. This is positive 92. I have 2 real roots again. So this is the discriminant. We'll need this. Hopefully, we've done B squared minus 4AC enough that it sounds like something. But now we're going to go ahead and solve for x. So I need the rest of the quadratic formula. I'm going to change the sign on B, so I'll put negative of whatever B is. And plus and minus, this is a combination symbol here. Square root of whatever the discriminant turns out to be, divided by 2a. To start, we need an equation that's in standard form. This one is, and equal to 0. Then we identify a which is 2, B, which is 8, and C, which is 1. First, I'll find the discriminant. It's our take attendance alarm. Okay. B squared minus 4AC is 8 squared minus 4. This doesn't fit here. Eight squared minus 4 times 2 times 1. So I have 64 minus 8. That's 56. This is a positive number, so I'll have 2 real number solutions. Then I continue solving. And I'll substitute into the rest of the quadratic formula. Negative b plus and minus square root of the discriminant divided by 2a. The discriminant was 56, so I put that under here. B is 8. A is 2. So this is my what I'm working with next. I need to simplify this radical. 56 is not a perfect square. So I simplify the radical. I'm going to write it over here. Let's see. My factors are, I'm going to factor using my calculator. We just talked about how to do that. You go to y equals, type the number that you want to factor and divide by x, and then look at the table. Hmm. 4 times 14. That's the only one I can see that has a perfect square. 14 is 2 times 7. So I can't break that down. But I can do square root of 4. Square root of 4 is 2. And I'll leave the 14 inside the radical. So I have negative 8 plus and minus. Instead of square root 56, I'll write 2 square root 14. This is divided by 4. 2 times 2. I can simplify this fraction if I divide each of these integers by 2. Don't mess with the square root 14. We already simplified that as much as we could. It's just going to stay square root 14 now. X is negative 4 plus and minus square root 14 divided by 2. I say plus and minus because this is negative 4 plus square root 14 over 2 and negative 4 minus square root 14 over 2. Any of these are fine. You can leave it this way with the plus and minus combination if there's not any other further simplifying to do. So either way you write it is great. Okay, next. Last, if you like to think of it that way. I have a quadratic equation because I have something squared. It's not in standard form. I need to move this 1 and set this equal to 0. So I'll have -5 x squared plus 4x plus 1 equals 0. A is -5, B is 4, C is 1. First, I find the discriminant. B squared minus 4AC. I substitute 4 and -5 and 1. This is 16 minus, okay, minus, that's plus 20. So I get 36. Then, oh, I didn't put a step 2 on here. We do the rest of the quadratic formula. So first, we do the discriminant. Then we do the rest of the quadratic formula. So I'll have x equals negative b plus and minus square root of b squared minus 4ac, which we just found is 36. And this is all divided by 2a. B is 4. A is -5. Next, we reduce the radical. Thankfully, this time we have square root of 36, and that is a perfect square. It's 6. So we don't have funky stuff carrying around here. I have x equals -4 plus and minus 6 divided by -10. And this can be simplified better. So for this, it's important to break this out into -4 plus 6 divided by -10. This is 2 over -10, which is 1 over -5. And -4 minus 6 over -10. This is -10 over -10. So this is 1. You have practice problems to do. Work through those. Let me know if you need any help.